Hello everyone. So in the last class we have studied the concept of antiderivative and how to find the antiderivative of certain functions. Okay. So we know that if d by dx of f of x is capital F of x, then we call that f of x is the antiderivative of capital F of x. Okay, so small f of x is the antiderivative of capital F of x. So antiderivative is that function whose derivative is the given function. Okay, now we will see example 3. Find the general antiderivative of the function f of x equal to x raised to 4 plus 6. So we have to find its antiderivative. It means we have to find a function whose derivative is this f of x. Now we know that d by dx of x raised to 5 is 5x raised to 4. So we got x raised to 4, but here 5 is an extra term. It means that we have to divide by 5. So we will consider division by 5. So if we consider the term 1 by 5 x raised to 5, we see that its derivative is 1 by 5 into 5x raised to 4, and this is nothing but x raised to 4. So it means that 1 by 5 x raised to 5 is the antiderivative of x raised to 4. And we also know that d by dx of 6x is 6. So 6x is the antiderivative of 6. So what is the antiderivative of this function f of x? We can write this as the antiderivative is we will get 1 by 5 x raised to 5 plus 6x. Plus we have seen that the antiderivative is not unique. So plus c, where c is the constant. Okay, where c is the constant. So this is the antiderivative of the general antiderivative of the function x raised to 4 plus 6 is 1 by 5 x raised to 5 plus 6x plus c. So I hope this is clear. Now we will move on to the next example. The acceleration of a falling body near the Earth's surface is 9.8 meters per second. If the body has a downward velocity v0 at t equal to 0, what is its velocity at time t? If the position is x0 at time 0, what is the position at time t? So this is the question. Now the figure is also given in the problem. So here we will measure the position x in the downward direction, and suppose that v is the velocity. So x is the x of t represent the position, and v of t is the velocity at any time t. Okay. So you can see that this is the body, it is falling down, and we have and its acceleration is given to be 9.8 meters per second, and the downward velocity is v0 at time t equal to 0. That is at the initial position. When time t is 0, its velocity is v0. So we know that acceleration is nothing but rate of change of velocity. Okay. So acceleration is rate of change of velocity. So we can see that we can write that dv by dt, that is rate of change of velocity, is acceleration, and it is given to be 9.8. Now we have, so first we will find what is velocity. So derivative of velocity is 9.8. So we have to find, to get v, we have to find the antiderivative of 9.8. So what is the antiderivative of 9.8? So v of t will be, so antiderivative of 9.8 will be 9.8t. Okay, because we are differentiating with respect to t here. So when you differentiate 9.8t with respect to t, we will get 9.8. So antiderivative of 9.8 is 9.8t plus c, an arbitrary constant. Okay. Now what next is given is, if the body has a downward velocity v equal to v naught at t0 equal to 0. That is, velocity v is equal to v naught at time t equal to 0. So when you put t equal to 0 in equation 1, so equation 1 implies that when t equal to 0, v takes the value v naught. So LHS become v naught, t is 0, so v naught equal to c. So again one becomes, equation 1 becomes v of t equal to 9.8 t plus v naught. Okay, so this is our, so in this way we got the velocity v of t. Now we know that velocity is nothing but rate of change of position. Okay, so position we have denoted it by x. So we know that velocity is nothing but it is dx by dt, rate of change of position. So dx by dt is 9.8 t plus v naught. Now we derivative of x is given. We have to find what is x. It means that we have to find antiderivative of this function 9.8 t plus v naught. We have to find the antiderivative. Now what will be the, we know that d by dt of t square is, we know it is 2t. Okay, but we want 9.8t. We want a function whose derivative is 9.8t. So it means that this 2 we have to divide by 2 and we have to multiply with 9.8. So we can take the function as d by dt of 9.8 by 2 t square. Okay, we have divided by 2 and multiplied by 9.8. So this will be 9.8 t. Okay, so and d by dt of v naught t is v naught. So we can write that x of t equal to 9.8 by 2 t square plus v naught t. V naught t is the antiderivative of v naught. Plus we will get a constant. So again a constant, we will denote it by d plus d, where d is a constant. Okay, d is a constant. Now we can see that in the problem it is given, if the position x naught at time, if the position is x naught at time 0, what is the position at time t? That is the question. So position is x naught, that is x is equal to x naught. It is given that x is equal to x naught when t is 0, when time is 0. So we will substitute in equation 2. So equation 2 implies LHS is x naught is equal to time t is 0. T is 0, we will get x naught is equal to d. So now 2 becomes, so 2 becomes x of t equals 9.8 by 2 is 4.9. So 4.9 t square plus v naught t plus x naught. Okay, so we got the position x of t. The question is, what is the position at time t? So the position at time t is x of t is 4.9 t square plus v naught t plus x naught. Okay. So we have done some problems in which we found antiderivatives of certain function. Now we will see the notation of antiderivative. So what is the notation of antiderivative? Antiderivative. So this notation is given by the mathematician called Leibniz. Sorry, this Leibniz. So Leibniz and Newton are the one who are known as the who invented calculus, who founded calculus. Okay. Now the notation of this antiderivative is given by Leibniz and the symbol is like this. So this is the notation of antiderivative. So if you want to find the antiderivative of f of x, so antiderivative of f of x means you have to do integral f of x dx. Here x dx, we use the variable x since the derivative is with respect to x, so integration antiderivative we denote it by dx to show that x is the independent variable. Okay. So this integral sign was introduced by Leibniz, and this anti-differentiation is also called integration. Okay, this is also called integration. Anti-differentiation, that is the thing we found the antiderivative of certain function. That function is called integration. Okay, so differentiation and integration. Okay. So if I write integral f of x dx, then we say that here f of x is called the integrand. Okay, it is the integrand. The function which is to be integrated, it is called the integrand. And integral f of x dx is also called the indefinite integral. It is also called the indefinite integral of f of x. It is called the indefinite because the limits are not finite. Okay. So if the limits are finite, they are said to be definite integral. So here we have the indefinite integral. So the antiderivative is also called the integration. So integration, we use this symbol to find the integral. Integration of some function like x square, like that. So we know that this integration, we use this symbol, and here x square is called the integrand, and this integral x square dx is said to be indefinite integral of x square. Now we will see certain notations and properties. So an antiderivative of f is a function capital F such that its derivative is small f. So we write f of x equal to integral f of x dx. The function integral f of x dx is called the indefinite integral of f, and f is called the integrand. Okay. If f of x is an antiderivative of f of x, the general antiderivative has the form f of x plus c. So this is a general antiderivative. We have discussed it in the last class that the antiderivative is not unique. So if f of x is an antiderivative, then f of x plus c, for where c is a constant, is also antiderivatives. Now we will see some rules for finding and integration, that is the anti-differentiation rule. So the sum rule. So integral f of x plus g of x dx is same as integral f of x plus integral g of x dx. So integration of sum of two functions is same as sum of their individual integrals. Then we have the constant multiple, that is integral, that is if you have integral 2x dx. So it is same as 2 is a constant, you can take it outside, it is 2 into integral x dx. Here x is the variable. So constants can be taken outside the integral sign. okay, and can be integrated. Then we have the power rule. Power rule is the important one. You have to remember this. That is integral x raised to n dx. Is the power rule says that it is x raised to n plus 1 by n plus 1 plus c, where c is a constant. And n is not equal to minus 1, because if n is minus 1, then this denominator becomes 0. Okay, so this quantity will not exist. So for n not equal to minus 1, integral x raised to n dx is x raised to n plus 1 by n plus 1. So this is the formula for integration that we have to remember. You have to study these formulas correctly. Then polynomial. For polynomials, how do we integrate? So we are applying this rule, power rule here. So the power rule says that integral x square dx. What is integral x square dx? Power rule says that, so here n equal to 2. So it is x raised to 2 plus 1 by 2 plus 1 plus c. So which is nothing but x cubed by 3 plus c. So this is the, so in this way we can apply the power rule. Okay. Now for a polynomial, you can see that the polynomial is of this form. Okay. So we have a polynomial like c0 plus c1x plus etc. cn x raised to n dx. This is a polynomial. So by the sum rule, we can write this as integral c0 dx plus, now constant can be taken outside, c1 integral x dx plus etc. It is cn can be taken outside, x raised to n dx. Now, if you take c0 outside, this is integral dx. So this can be considered as integral x raised to 0. X raised to 0 is 1. Okay. This can be considered like this. Remaining terms are same like this. Okay. Now here x raised to 0. If you apply the power rule, you will get it as x divided by 1 plus c1 integral x. Apply the power rule. So x raised to 1 plus 1. So x square by 2 plus etc. Last term cn integral x raised to n. By the power rule it is x raised to n plus 1 by n plus 1 plus c. So in this way we can differentiate the polynomials. So study all these rules thoroughly and see how we are deriving these values and how we are integrating polynomials and how we are writing the power rule. Okay. Now we will prove the power rule. That is, we have integral. We will prove that integral x raised to n dx is equal to x raised to n plus 1 by n plus 1 plus c, where n is not equal to minus 1. So for this, integration is nothing but antiderivative. So we know that derivative of so we know that d by dx of x raised to n plus 1, d by dx of x raised to n plus 1 is, what is the derivative? It is n plus 1 into x raised to n plus 1 minus 1, so it is x raised to n. Now we have to find the function whose derivative is x raised to n. Okay, so we have to, so here should be x raised to n, here we have n plus 1 also, it means we have to divide by n plus 1. So we see that d by dx of 1 by n plus 1 x raised to n plus 1 is x raised to n. So this implies that integral x raised to n dx, that is the antiderivative of x raised to n, is 1 by n plus 1 x raised to n plus 1 plus a constant c. And also we can write n not equal to minus 1. because if n is equal to minus 1, the denominator here n plus 1 will become 0 and this term won't exist. So n is not equal to minus 1. So you can remember the power rule and you can do many problems using this. Okay. For example, suppose you want to find integral 1 by x square dx. So here also we can apply the power rule because this is x square is x raised to minus 2 dx. And it can be written as x raised to, by the power rule it is minus 2 plus 1 by minus 2 plus 1. So this become x raised to 1 minus 2. So it is minus 1 by minus 1. So which is nothing but minus 1 by x plus c. So this is the integral. So in this way we can find integral of 1 by x square. Okay, so we'll continue in the next class. Okay, thank you.